previous video where I had implemented two overlapping squares. This time I'll be implementing three shapes, that is a circle, a triangle and a square, which are non-overlapping. So yeah, to implement that, I'll be changing the code, tweaking the code to generate the same. So just for revision, uh, this is our VGA controller block, which basically, sends out the coordinates and this image source, which basically generate the RGB values based on those coordinates and send it to the DAC, and the DAC will send the analog value to our monitor, which will be displayed. So building on the same, here is the code, which is the standard pixel clock. As I said, it is the reference clock for our pixels to be displayed, and display enable to show the display region where we are displaying our image, the column and the row being the coordinates for the row and the column. As we move from left to right, that would be our column, and from top to bottom, that would be our row. So yeah, and then we have the RGB output, which are basically used to send out the image to the particular pixel. Now let's define few of the constraints or static assignments here. So this is my screen dimension 1920 by 1080, and this constant size is the reference size that I'll be using for all of my shapes, that is the circle, triangle and a square. So this would be our reference size. So I have done half of size and sent that to radius. So our radius is basically half the size. This will be used for the circle generation later. Now we have the thickness. As we want to draw the shapes, we want certain thickness to the shapes because we are drawing unfilled version of the shape. So it will be having boundaries, so it should be having thickness. So I've defined some thickness here for our circle, triangle and square. So these are not the final thickness, it's just that a reference value to where we start from. Now we have constant called as spacing. Now spacing is the gap between the shapes that I have defined. So since I don't want them to be overlapped, there should be some spacing, right? That's the spacing. Now we have group W. This group W is nothing but the space within which I'll be drawing all my three shapes with including the spaces. That's why I have 3 into size plus 2 spacing. So 3 into size is basically for the size of the circle, triangle and the square, and the 2 spacing is the 2 gaps between the circle and the triangle and the square. So that's why it will be 2 into spacing. That will be the total uh, space within which I'll be drawing my shape. Now to uh, have a initial or a starting coordinate along our x, we'll subtract the total screen width with the spacing and divide it by 2 so that we can center it to our screen. So if we want to center it to our screen, we want to have equal space towards our left and right. So having done that, you get your starting position along your x, and similarly I've done for the y, where I've divided the vertical space by 2. So now we have the starting position for our x and y coordinates. Now we want to have the center for our shape. So for the center of circle, we have the starting position and the half. As I said, half is nothing but the radius, so that point would be our center for the circle, and for our triangle it would be this plus the spacing plus the size of the circle. So that's why you have the triangle center there, and for the square it would be this plus spacing and the size, that would be for your square. So these are the centers for your circle, triangle and square for reference. Now here is pipeline of registers where I've defined it as signals for queue, for column, row and visual. So this is nothing but I displayed it for display enable. This is for display enable, and this is for whether check if it's a circle, triangle or a square, and this is the RGB values that will be sent out. So the need for this is that initially when I had done my other iterations where I had not defined it as registers, there was a miscommunication or a gap between the computation of this and this RGB values. Basically, whenever when I used two separate processes for calculating this and this value was sent out this value was sent out, and the previous value of the RGB calculated for the previous coordinates was sent for the coordinates that was sent for this. So basically, due to that mismatch, the shapes were not coming out to be good. There was some bleeding around the edges, which is not ideal. So yeah, that is why, to maintain the synchronicity, or to keep it all synchronous, I have defined this registers from where we'll be taking out the values. So that is why we need this pipeline of registers. Now coming to how I'll be coming to the important block, the shapes. Now I've defined these variables. So this is for the circle, the x and the y coordinates. The x and y coordinates for a circle that we want. This is the general coordinates, and then the absolute value for the same, the distance from the center, and the inner and the outer radius for the circle. And then we have the top and bottom, and basically the height for our triangle. And then we have the left edge, left slanting line, and the right slanting line defined here. And the apex is basically the thickness that I'll be talking about later when I'm explaining about the triangle. And this is for the square that we have, the along the x and the y, and this for vertical and horizontal, these are basically the flags. So let's, and also I've saved this temporarily. I've created this called circle, C, triangle, and square. These are basically the flags that will indicate whether we are drawing, if V circle is 1, that means that we are drawing a circle. If V triangle is 1, it means we are drawing a triangle. So basically these are flags to indicate which shape are these values being sent out, the RGB values are sent out, or the coordinates are for. So yeah, we start with our logic. If at the every rising edge of pixel clock where our calculation is made, we assign the column, row, and display enable to our column, row, and visual registers that I've defined earlier to maintain synchronicity. And the other thing that I forgot to mention was about why I'm using variables here, because previously I described this as signals, but I'm describing it as variables here. So the need for variable is that the variable's value changes throughout the process. Like within a process, the variable's value can keep changing continuously. But if you look at the signal, the value only gets latched towards the end. So which means that you can't really have that, what can you say, the freedom of changing values continuously. So that's why I've used variable here instead of signal. Now let's continue. This, as I said, this will be our coordinates for x and y to map the shapes. And by default, we have said that we are neither drawing a circle, triangle, or square. All these flags are set to 0. Now let's start with our circle here. Now to get the x offset, it is x minus center of circle. So our center of circle, as I explained here before, is nothing but the starting position plus the half. That would be our center for the circle. That is the center coordinate. Now from the center coordinate, if we subtract x, that is if we move towards the left, if we are moving towards the left, x minus center of circle, x minus center of circle towards the right. If this is positive, it will be towards the right. If it's negative, then this will be towards the left. So that's how you get your x coordinates with respect to the center of your circle. And then similarly you have the y coordinates with respect to the half or the center that we found for our vertical reference coordinate. Now we have the absolute, we'll be taking the absolute values of dx and dy, so that we don't have to do unnecessary calculations, or to make our calculations easier rather than to do unwanted calculations. So yeah, here I'm defining a certain boundary here. If the x coordinate is within this boundary and the y coordinate is within the boundary, then we calculate the distance, Euclidean distance of dx square plus dy square. So this boundary I'm defining is generally so that we don't do any more unnecessary calculations. So yeah, and I've also used the Euclidean formula because it is easier to implement, as we'll be using multipliers and the adders instead of taking out the square root to find the square distance. And yeah, so that's why I'm using this. And then I'm defining the inner and the outer radius here. The inner radius is radius minus the thickness of circle plus 1. I'm basically squaring the inner radius here. So why I have defined this is that this will be our inner circle boundary. Since I'm drawing an unfilled circle, it should have an inner radius and an outer radius, and within those two regions you'd want to draw your circle. So yeah, um, you'll be having your radius of your circle now minus the thickness that I defined earlier as 3 plus 1 would be the region for your inner, that would be your inner radius region, you could say, or the circle. So that is why I've defined this, and the 1 is specifically because if whenever I defined it as this T circle before, the T circle is an absolute value. So what it used to do was it used to have a stringent value, which meant that there was a the circle calculated was not uniform. It had some, the left half was different from right half, or you couldn't see the left half. So this basically adding 1 gave that leeway so that the radius calculation was the inner radius calculation was better. If inner radius is less than 0, then we set it as 0, because we only want greater than inner radius to map our or to draw our circle. And similarly, I defined the outer radius as radius plus the thickness of circle plus 1 to find out the outer radius and square the same. So now we have defined the outer and the outer radius and the inner radius of a circle as our boundaries. Now if the distance is greater than inner, the distance that we have calculated here is greater than the inner defined radius, and the distance is less than the outer defined radius, that is the spot where we want to draw our circle. So that's when you have the V circle flag to be 1. So that in that region you'll be drawing your circle. So this is the idea of drawing the circle. Now let's move on to drawing a triangle. Now for triangle, I've defined y top and y bottom. So we have the, as we calculated before, I have the half coordinate here. Whenever we move towards the top, it is base y minus half. As you subtract something from base y is your what you call the base vertical length that we had found earlier. If you subtract half from that, if you subtract half, you go towards the top. As the calculation is always done from top to bottom, you move towards the top half, which will be your apex, and if you add half to the base reference line, it will be your bottom where you'll be drawing your base. So that's why we have defined y top and y bottom. This dn is basically a fancy way of defining height, which is nothing but equal, it should be equal to size. As you can see, y bottom is nothing but base y plus half. When you subtract this, it becomes 2 halves. You get 2 halves. 2 halves is nothing but equal to size. So that is what den is nothing but equal to size. Now let's start with calculation. If y is greater than y top, if we are moving downwards, and y is less than y bottom, if it's within this space, that is where we need to, that is our area of interest. So if we are within that region, this left x will calculate basically the left slanting line, and the right x will calculate the right slanting line, or what the coordinates or the boundaries for the left and the right. So that is what we have done here. And then, since we'll be drawing a triangle and the edges that are meeting towards the top must be sharp and not a blob, that's why I've used this apex tool. Basically, at the apex the thickness should be less so that it becomes a like a sharp edge towards the top. That's why towards the apex, first two rows, as we approach towards the first two rows, the thickness is reduced so that it becomes sharp. Else, in every other region, the triangle thickness that I defined earlier is maintained. So that is what is being done here. And then finally, we have the condition where we need to draw the triangle. That is, if we are at the left slanting slope and if we are at the right slanting slope, or this basically defines the base. If we are at the base region and within the boundary set by the left and right, then we draw the triangle here. That is what you have done here, and that is how you draw your triangle. So you basically define the boundaries, and if we are within that, then we make it a triangle. Now similarly for square, it's pretty easy. So we take the x coordinate, and for the x coordinate you need the center of square x, which we had defined earlier, and for y coordinates along the y you need the base y. This is basically to extract where you are as of from the centers of what we have calculated. Now to find out y, for drawing vertical lines here, you calculate the half distance from them along the x and then you draw the vertical line. So that is what it does, and this is just so that you stay within the boundaries and you're not exceeding beyond the boundaries of the square. And similarly for horizontal, you look vertically up from the half, either to see if you have reached the top half or the bottom half, and then again to check whether you're to keep in check that you are within the square defined boundaries. And then if that is the condition, if if this or this is satisfied, then we are drawing, or the flag of square would be 1. So that is how you draw your square. Now, as I said, to maintain synchronicity, I have defined all of these back into a separate register. So yeah, I'm sending those values back into this. Now for the next half, this is basically how or what color I'll be plotting, or what RGB output should be sent out for each of it. So if I'm in, or if and if only if I'm in the display region, and if it's a circle or a triangle or a square, then I'm going to be sending R value to be 1, R flag to be 1, and other both to be 0, which means that basically my shapes would be red in color. Else, if other else, we'll have the red to be 0, and GB will basically combine to form that green background or the teal background. So that is how we are gonna, the background will be teal and our shape will be red in color. Else we're gonna keep it blank. Now, as I showed from the diagram, these values should be driven to the DAC so that it can send the its uh, analog values for the monitor. So that's why I defined this to send out the outputs. Now let us look at the compilation report for the same. Now you look at the ALMs, it is 24 and it is used 39 ALUTs and it has 24 registers and 31 IO pins. And certainly, just like the last time, we have used PLL to synchronize. We always use the PLL to synchronize with the monitor. So that's why we have that one global clock here. And yeah, as I said, if you want to look at the design, it will be the same as the previous video, because the the pretty much implementation is still the same. It's just that I'm just changing the image that I want to send out onto our screen. So the pretty much every other thing would be the same. So now I'll be implementing it on the FPGA and showing the result on my monitor screen.
So let's go ahead and implement the program. As I said, this is the VGA input. We are driving it from the FPGA onto a monitor here. Here I have the dumping cable for the bit stream and the USB for the monitor. Let's go ahead and run the program. You can see we have obtained a clear output of circle, triangle and a square which are equally spaced. Thank you.